HyCLo. HyCLo makes machines that makes biocides, disinfectants, and cleaners. The precursor materials that we make these chemicals from is just salt and water and electricity. In fact, we mimic the process that the human body uses for natural disinfection. When you get a cut, white blood cells goes there, and the chemical that white blood cells kill bacteria with, we make that same chemical. These chemicals are only partially stable. They only last a matter of hours to a matter of days. So when they start with salt, water, electricity, after hours or days, they fall apart again back into water and salt, salty water. So that's why you've never heard of this type of chemical to buy at the store, simply because you have to have a machine that makes it. It has to be made on site, on demand. So just to be clear what a biocide is, if you're very small, if you're a virus or a bacteria, if you're a mold or a fungus, we've got you in our crosshairs. And if you're a larger organism, if you're a chicken or a cow or a guinea pig or a human being, it's absolutely non-toxic. And it's part of the biochemistry of this chemical. It's absolutely non-toxic chemical to larger mammals. To mammals, to those guys, it's a big problem. So this is a good idea. So it makes sense that people agree that the technology works. But it's simply not enough. What we bring to the table is it's the absolute lowest cost solution. The precursor materials are simply industrial salt and water. So and the amortized cost of the tool. So the cost of the disinfecting and cleaning liquid is so much lower than conventional mechanisms. So we provide the cheapest chemical and the best chemical, and this drives the customer. We call it irresistible. The net effect is there's no transportation, there's no burning of hydrocarbons for transportation, there's no containers, there's no drums at the manufacturing plant, there's no organic and inorganic reagents, simply because it's all made on-site, on demand, from salt and water and electricity. So today, we've made big tools. Big tools are easy to do. The technology is easy. In fact, Michael Faraday was probably doing this technology in 1860. The fundamental electrochemistry is well known. That's interesting. But what's really going to be interesting is not the very large, the very small. The lower picture there is a 1 centimeter cubed, same tool. So our vision, our future, is a tool that goes inside the squeezy bottle. Every one of you probably have dozens of these things underneath your kitchen sink, your counter. They might be used once or twice or a few times, but it's ultimately destined for recycling from landfill. We believe we can make a device that goes in here for pennies. Pulling the trigger supplies the electricity. There's onboard electrical generation. The chemical is not made, the cleaning and disinfecting chemicals are not made until you actually pull the trigger. If a little kid gets inside this, your pet gets inside this, they just get salty water. There's no toxic materials to be found until the actual trigger is pulled. That's going to be the fundamental change in the way people buy and consume chemicals. The antibacterial market, the disinfectant market, is hundreds and hundreds of different compounds. It's a huge, huge market. The EPA today has over 6,000 biocides listed. About 60% of those are for medical and hospital use. But it's big, big business. It's not often that people talk in the popular press about hypochlorous acid. It's not a topic that comes up every day. In 2009, there's a professor, Joellen Fiertag, at the University of Minnesota. She's a food scientist and microbiologist. Said that the ability of hypochlorous acid, it sounds too good to be true. This is actually one of the things that we find because it is so safe, it is so cheap, it works so well, it doesn't cause MRSA, it doesn't cause any of the problems that you see with the majority of disinfectant compounds. And the fact that it's ubiquitous, it sounds too good to be true. But she goes on to say it's only a matter of time before this becomes mainstream. And we believe that the time is now.
Okay, so if proving efficacy or getting the message out about this is the biggest hurdle, what are you doing to address that?
Well, I would say that's the biggest hurdle. The proof of efficacy, we've collected over the last 2 years 250 peer-reviewed publications that we had nothing to do with that are chronicling the disinfecting efficacy of hypochlorous acid. So not to mention those 250 publications cells from the beginning of time to the present day proves its efficacy. When people have a microbiology background, people that drive purchasing decisions at large chicken farms or large agricultural farms, they know what hypochlorous acid is. They know about that.
Can you run us through your economic model, talking about, are you selling these machines? Are you actually selling this more modular
Yeah,
device?
so for
And
today,
what are the economics of that and the cost savings and the return on investment to your customers?
yeah, so there's a couple of answers there. So we're selling machines. That's what we sell today. What we will be selling is the large scale machines. The return on investment is absolutely individually market driven. Again, the cost of the liquid is simply the salt, water, a little bit of electricity, the amortized cost of the tool. So it winds up being a quarter per gallon or something like that, maybe even less than that. So it absolutely depends on if that market is spending $20 for a liter of disinfecting liquid or $3 for a liter of liquid, and how much they're buying over time. So the implications are completely market specific and chemical specific.
How much are you looking for now, and what do you project in your return to investors?
So there's a couple of answers to that. So today the company has been completely self-funded. We turned down funding on a couple of occasions. We are far down the pathway with a couple of European grants for funding this, especially the Welsh Assembly government has grant programs to develop green company. In the U.S., we're looking for $5 million at a B round to get us up and running.
Can you talk about the team, management?
Yeah. So the four founders have all worked together at different companies for about 20 years. I come from a semiconductor and physics background. I started a company was co-founder of Neophotonics Republic, I guess February of this year, about $500 million in revenue. Our CTO, PhD, Chicago, executive roles in semiconductor. In fact, he invented the brush ribbon mechanism that's popular in semiconductor processes today. Our fabrication partner in New Hampshire has a 25,000 square foot fabrication facility for making tools and things like that. And our COO is heritage from Raykin, Polaroid.
Anything patentable?
Yeah. So as you might imagine, at the most base level, not so much. The electrochemistry is done a long time ago. The actual specifics of the tool, absolutely. There's much subtlety and much nuance and much. For example, the scalability of this is essentially without limit. If you need twice as much liquid, concatenate twice as many cells together, twice as many planes of the cells together. So it scales without fundamental physical limit. So all of that is novel to us and in the works.
So yeah, have you achieved that yet? And do you have the patents? And then what does the rollout look like?
Yeah. So as far as have the patents issued, absolutely not. There's those things along year after year. There are several dozen that are in the pipe, anywhere from provisional to pretty far down the path. The product rollout, we have machines in some customer sites today. Because we're in the Silicon Valley, we've got some other kind of people that are very interested in this that we don't have to sell them or give them a machine. We're actually able to sample, so we can deliver liter bottles to them that's freshly made.